take it away.
All right. Thank you, Chris. Again, my name is Suchen Chodankar. I'm a Senior Product Manager at Reltio, responsible for matching product feature of the platform. I've been with Reltio for more than 6 years, and I have close to 16 years of experience in the MDM space. I'm super excited to be here and to take you, walk you through this rule-based matching and how it works. Like Chris said, we are going to do a deep dive here, and the purpose is to really show you something or share the details, how the matching works, how it really works from the internal components, and what are the different things that are involved and things like that. So we'll spend a little bit time on that. So these are the topics for discussion today. We'll just talk about what matching is at a very high level. And then we'll get into the match rule anatomy, which is basically how you write the match rules or what are the different components of the match rule. And we'll spend more time on this matching process, how the overall matching works behind the scene. What is the tokenization? I'm sure you might have heard about this. People talk about tokenization. This is a big deal when it comes to matching. So we'll try to explain what that is and how it affects your performance, your outcomes, and so on. Then we'll talk about the comparison, and we'll show you a few examples with some examples on different scenarios and how this tokenization and comparison basically can be used there. Before I get into the match overview, I want to spend a few minutes in just summarizing the session that we had on the match last month. It was presented by one of my colleagues, Joel. So I want to kind of just do a quick recap here and just go from there. So Joel talked about the match rule lifecycle, and he explained how the data analysis and profiling is followed by basically design and implementation and testing and tuning. Data analysis, he talked about how match attributes can be selected based on the profiling result or should be selected based on the profiling result. The uniqueness, completeness, cardinality of the attribute, how it should drive the configuration for optimal matching outcome. And in the design and implementation section, he talked about the tokenization rule again, that it is tokenization, and he talked about the ignoring token as well, like how that changes your outcome or basically can hurt your performance or can basically improve your performance, right? And what is the optimal token intersection and token count? And finally, we spent some time on the testing and tuning tools. We use a verified API for troubleshooting, match rule analysis for verifying and correctness and completeness of the configuration. So what we'll do today is basically, as I go through my presentation, we'll try to dig a little deeper on these areas, and we'll show you some of the APIs that you can use to understand what is really happening in the background. Some of the questions that were asked, and we'll try to answer this through my session today. Is there any performance implication of having redundant match rules? Do we rebuild only when the match rules are changed? What are the match-related jobs we need to be aware of? How undermatching or overmatching is related to tokenization? Is there any limitation on the number of match rules that we can configure in the Reltio platform? So these are some of the questions that were asked, and we'll again get through this as we go through my presentation. So a lot to cover, so let's dive into it right away. Matching, as we all know, that it's a process of identifying records that are same or related to each other. I've used the second use case here, related. Usually when people talk about matching, they talk about basically finding two records which are same, duplicate records. In Reltio platform, you can configure to find records which are related as well. And we'll look at that one example for this use case as well. So there are two methods of matching that Reltio platform supports. One is a rule-based matching, which is what we are going to talk about today. It's a instruction-based matching where configurator provides the instruction and platform execute the matching based on those instructions. We have a second kind of matching method, which is machine learning-based matching. In this type of matching, customers basically build their match IQ model. It's a machine-based model for matching records. And the third thing I want to cover here in the matching overview is the supported action. So once the match pairs are identified, once you know that John and John is a similar or related record, what do you do with that? That's the second part of the matching, the action that you can perform either automatically or manually on that pair. So these are the supported action in Reltio platform. We have automatic merge. This is a system triggered action, which means you can configure a platform to trigger this automatically to merge two records or mark as not a match. This is user triggered action, which is provided to the data steward while they are resolving the potential matches. Then we have a way to present a potential duplicate record for review to be merged or to be related. And finally, the last one is the published matched pair. This is, again, you can say, John and John is a match, but I don't want to do anything in Reltio. Just share that detail with me, and you can do that as well. So this is a high-level matching overview. There's a lot of detail in here, and we'll try to cover that as we go through the presentation. So match rule anatomy. So I talked about match rule-based matching, where you write the instruction. So what that instruction look like, right? So it's not just saying that match on the first name, match on the middle name, and match on the last name. And if all these three criteria match is true, then a pair should be a match. So in addition to those instructions, there are a lot of other things that you can configure in Reltio, which provides you better flexibility to address your use cases. So I'll go through this different fields or properties that we call them of the match rule. I'll start from the top. This is the URI. So which is basically the unique identifier for every match rule. You could have basically multiple match rules. You could have 10, 15, 20. Every rule has to have its own identifier, unique identifier. That's what this URI is. A label is basically the display name that a data steward will get to see when they are presented with a potential match, matching this match rule. Type is basically, and I'll cover this actually in the next slide. So I'll talk about this in a bit. The scope of the matching is basically you get to define whether you want to use this match rule for intra-tenant matching, which is basically matching within the tenant, or external, which is basically matching external file record with the Reltio tenant. And of course, it's both. You can do both as well. Use OV only. So we have an example to demonstrate how this flag or this particular property affects your matching. This is basically to say whether you want to use only the surviving value of the profiles, or you want to use all values, surviving and non-surviving, from the two profiles that you're evaluating for match. Then there is a rule section. So this is where the instructions that I was talking about, this is a section where you write that instruction. So there are different components to it. Ignoring token, match token, these are related to the tokenization scheme. Comparator classes is basically you get to define a specific comparison function. And this right here is basically your statement of matching, where you use the logical operator to build any complex match tool that you might have. As you can see here, there is the exact, there's a fuzzy, and there's a cleanse here. So I will show you one example as well, and how to read through this one. And finally, not visible on my screen here, score standalone and score incremental. Now this is one other property that can be used to facilitate searching of the potential matches faster. And again, we have example for that as well. I'll talk about that as well. All right. So just to kind of summarize the match rule configuration, when you look at the match rule configuration, it is divided into two categories, really. The one is the matching logic, which I talked about, the cleanse rule, the tokenization rule, the comparison rule, and there are other other parameters like um, OV value or not. And then there is a scope and other stuff. But there is a second part to this configuration, which is match action, or what kind of match action. So I said I'll talk about that type. So this is what I wanted to show. So there are three categories of types that you can have: binary outcome based, relevance based actions, and custom type. Binary outcomes are basically either the match rule or the pair basically goes through the matching using that match rule and comes out as a match or not a match. So that's a binary outcome. There is no gray area there. Relevance-based action basically gives you that, the gray area in addition to the, true or false. So basically it gives you a score between a record that you're evaluating for a match, and you can decide whether that score score is good enough for automatic merge or for suspect merge or something else, right? And custom type is basically you get to define your own action. Basically, you can say that I don't want this pair to go through automatic merge. I don't want this to get registered as a suspect, and I don't want to show this to the data steward. What I want to do is really publish this pair so that my downstream system can pick it up and do whatever they have to do with that. So those are the three actions that are supported across these three category of match type. Before I show you a few examples there, I want to just go through this list of APIs that I wanted to share. It's already there on documentation portal. It's out there on the Swagger developer portal. You can use this to troubleshoot, tune your matching, and see what's happening when you look at any particular match pair. And if you agree that it should match and it is not matching, you can use this API, some of these APIs, to really kind of get more details around what is really happening in the background. So I'll just read through this, like match token classes. This is a list of basically token classes that are supported. Then you have comparator classes tokens. What you see here on the top, these are basically generic tools, meaning it is not tied to your Reltio tenant data. You can just provide any two values, for example, and say, hey, show me how these two values will match using this tokenizer or using this comparator. So you can just play around with it with any sample data without loading that record. So it's just like, two values that you're passing, Johnny and Jimmy, let's say, okay, show me how this will match using Fuzzy, right? So you can do all of that using this top listed APIs. At the bottom here, in the previous webinar, Joel talked about these verified matches. This allows you to basically get explanation behind any particular match pair. So you can just provide two IDs or two records and say how this would match in Reltio using the rule that I already have in my tenant. So this is the API we are going to use quite a bit today. And I'll show you how that works. In addition to that, you also have match document tokens and match token details. I will explain what these are once I get through the overview. Okay, let's look at the example. So this is my Reltio tenant, and I'm going to start with no records in the system. As you can see, I'm working with the I have 0 records here. And there are, okay, I can get this out of the way. All right. So as you know that you can basically look at the list of rules that are configured here using data modeler. You can get to that data modeler from this console application, which is available here. You can click on this console and get to the data modeler. As you can see, I have 5 rules here. So we'll talk about example for scope, which I mentioned earlier. So as you can see, the scope is internal. What this means is this rule will be used only for intra-tenant matching. So if you have your file you want to match with the Reltio tenant data, Reltio platform will not use this rule in that matching. Similarly, if you have a rule configured as external, then this rule will not be used for matching your tenant data. So I have other rules here. internal, then relevance based, and finally this is a type that I created for myself. I call it publish match profiles. You can just name it whatever you want. That's the custom rule type. So I have these 5 rules. So what I'm going to do is okay, the third scope, actually I forgot to mention this one, is the one, right, where you get to say that I don't want to use this match rules for any of my matching, so you can just sort of disable it for the time being. So that's what I've done. So I have just 3 rules that is working right now. So what I'm going to do is I'm going to load this record. I have this example. I'll just quickly walk you through this. So I have first name Philip, last name Carter, and they have I have a bunch of other records which are similar. They all have the same address. So second record is again Philip. It has the middle name R. This one is T, and the last one is Philip again, but this is spelled differently. But they sound same, right? So what I'm going to do is I'm going to load all of these records. Okay, let's see. Okay, while we have this records getting loaded, what I'll do is I'll just go and create new external match. I want to show you the scope part very quickly here. Okay, so the data is loaded. Before that, let me quickly show you this. So as you can see here, rule number 2 is the only rule which is visible to the external match application, which is what you see here. All other rules are not visible there. And I will demonstrate how this rule 2 is left out when you're matching the Reltio tenant data, even though the rule is exactly same. So it's exact last name, first name, and address, and this is exactly the same rule. Then I have the third rule, which is a slight variation of the first rule, exact last name for the first name, and also it has address there. I didn't mention that there. So let's look at the tenant data. Okay, so these are the 4 records that I loaded. As you can see here, Philip R. Carter, Philip T. Carter, Philip Carter, and Philip T. Carter. So just a slight variation, they all have the same address. So I'm going to open one of this record and go to the potential match. By the way, I've marked all of them as suspect just to kind of, demonstrate this one. You can use automatic, but then you won't get to see how they are basically matching or not. Right. So catch up as quickly as possible. So these are the 4 records that I loaded, right? So as you can see here, there are different scores on top. They are determined based on the number of match rules that this record has matched on. And you get to basically configure this score. I'll show you how we have configured it here. So these are the 2 rules that it matched on. As you can see, score standalone is 60 here, and the second one is 8. So what you see here, okay, it matched on rule number 1 and rule number 3, rule number 3 and rule number 1 here. So 60, and then it picks the incremental score 6. That's how I got 66. So it picks the highest incremental or standalone score first, and then for every other rule that it matched on, it will pick the the incremental score. Okay, so now I have what I'm going to do next is basically I'm going to match or merge these 2 records, this Philip record here and write this one. So after merge, what I expect is I still expect this Philip to match with this Philip. It will match, but you will see that it will basically not match on the exact, even though there is a Philip here and Philip here, right? So let me go ahead and merge these 2 records. All right, so it's going to get loaded. All right, and I'm going to go and refresh. All right. So as you can see, the score for this Philip record dropped now. So I don't have that exact match, even though I have this value here, the first name Philip. I don't have that, and score dropped from 66 to 60, right? So what happened here is like it is looking for matching only on the OV. You see that Philip here little grayed out. That's what it means. Basically, it means that it's a non-OV value. So let me go ahead and modify this record or this rule. And I can say for my rule number 1, which is exact, don't bother looking for just OV. Look for non-OV as well. So I'm going to go and post it. Okay, and I'm going to trigger matching on this records. When you change match rule, you have to basically run the rebuild match table job, but I'm just going to basically force them by just changing something in here, which is not part of the matching criteria that we're talking about here. So I'm going to just post this. Okay, let's refresh and see. Okay, let's do this one more time. Okay, as you can see now for this Philip record, the score bumped from 40 to 66, and now it is matching on rule number 1 as well, because now it is considering Philip with this non-OV value Philip as well. So before I take any questions, I want to show you those other APIs that I talked about, right? So what I'm going to do is I'm just going to quickly run through this. So I have my first record. And I'll take this second record. All right. Let me take this response JSON editor where we can see the detail. So as you can see here, it is showing me that rule 4, what is the outcome? And this is basically where you control which rule you want to evaluate. I'm looking for rule number 3. So I can basically get that response. And it says rule number 3 will equate or evaluate to true. And you can actually look at the additional details, like, how the individual components of that rule, like, this exact, whether it's matched, whether the city matched, whether the state matched. So you get basically more detailed explanation of how we came to that conclusion that these 2 records are same. Now, you can basically get more details around other things, like, what are the different tokens that record has generated. As you can see, there are 3 tokens here. You can basically get more information about the match documents, and I'll come back to this match documents in a bit. I'll pause there and I'll see if there are any questions I can answer.
Yeah, you want me to start asking those?
Sure.
Right. Yeah, so Chetan, I don't know if Gino answered your question completely. If not, just put it in the chat or just say no, and I'll come back to it.
Sure.
So first question I'm going to ask, can we design match rules to match a set of attributes to be concatenated, sorry, and perform match.
Mhm.
So example, address 1 plus address 2 plus city plus state plus pin matched, not applying them individually.
If I understand the question correctly, we are talking about a bunch of attributes concatenated, and you match
Yep.
that with maybe some one attribute from a different profile. If that's the question, the answer is no. You will have to basically kind of create that string or create that value and store it in a different attribute, which you can then use in your matching. So I want to go back to what Joel mentioned in his previous webinar, that standardization, right? So there is a way we can do that, using cross entity type or cross attribute matching and all, maybe. But the more complexity you bring into the match rules, the slower it will catch, right? And also you might basically hurt some other match pairs that you have or hurt other match pairs that you have liked, right? So trying to configure this match rule to fit in, right, with this complex, it will just going to kind of create more complexity. So my suggestion would be, if you have that scenario, create that concatenated string, push it to a different attribute. Let's call it like match attribute 1. And you have that other attribute, use a similar concatenation on the other record as well. And now you are matching the second attribute that you created.
That makes sense. And if that doesn't answer, please just post in the chat and we can get to it. So Sandro asks, can we match on a substring of a given attribute? So example, characters 2 to 7 of one of our crosswalk attributes?
Yeah, you can basically use a custom comparator to match substring, and if it's an organization name, that kind of thing, you can use like distinct word comparator. But if you're looking for like from 7 to 8 string or 7 to 11, so that is something that is not kind of easy to configure. But again, my answer is again same for this question. All this kind of scenarios that you have, it is always better to have a standardized kind of or a different attribute where you have kind of trimmed that down and put that in a different attribute. Remember, in Reltio, you can just go and create a new attribute in a matter of like seconds. So you just create that substring, push it in a new attribute, do the same thing for all profiles, and then you use that. And now you get to basically apply a lot of more kind of flexibility or different algorithms on that derived attributes.
Okay, that's a great answer. Are multiple match actions supported?
Multiple match actions are supported, and that is using basically relevance base. Like I said, for binary outcome, there is just one action that you can tie there. So if I go back to my rule configuration here, you will see that here this can be automatic, or suspect, or any other action like publish or something like that. But in the relevance, you can configure multiple actions. In this case, I have 0.91 to 1 for potential match. I can have another action, automatic merge. So you can have multiple actions, but that is supported for relevance-based matching only.
Okay. Does the tool create the file format for external match based on entity created in Reltio?
No, the external file is something that you bring. And it can be any, basically, if you're talking about the layout, then you get to bring any layout. The supported file format is CSV only right now. Once you get this different columns, you basically get to map it to the Reltio attributes. So as you can see, I've said that my first column is my first name in Reltio. So that's how you map it.
Okay. Do these rules have a hierarchy?
No, it does not. And that's a good question. And I want to basically go to the next section where we can explain that. And if there are other questions, we can take it at the end of the session.
Sounds good.
I just want to make sure that this is something that we can cover very quickly. So next we'll talk about, and we'll answer this question that Chris just asked, whether there is a hierarchy in the rule. So this is really what I wanted to kind of spend a little more time here on, like how the matching process works internally. So you all have heard of like Reltio UI, analytics, and other services like history, then activity log, and so on. So the way it works is you have the data load. Once the data is pushed into Reltio, we have something called as primary storage. It always lands there. Once the data is loaded in here, we have this CRUD queue, and you have access to that information as well. In your tenant management, there's a queue monitor that you that you can do. You can go to the queues, and you can look at all the messages that is flowing through this CRUD queue. So CRUD queue is basically, it receives every update, every new record that you push into Reltio is always placed here. And this queue basically then publishes it to all other consumers, basically, which takes the data and updates the respective component of Reltio platform. In this case, it's Reltio UI. So it will basically, whenever a new record is created, it will basically inform Reltio UI that there's a new record created. Please update the UI database and kind of show that record. The record is updated. It does the same. It does the same for analytics, other services. So let's talk about the match. So just like other services, match also receives a copy of that new record or the updated record. Once the copy is received, we immediately basically create a match document. I want to go back. I want to go back to the match document API here. So this is one of the entity that we just loaded. So this is what the match document looks like. So it has basically all the attributes that you've configured in your match rule across match rules. Basically, you have address, first name. As you can see, if you expand address, you'll have this sub attributes there. Along this raw value, we also have the tokens. What tokens we have created for this entity? What rules do we have in the system? All of that information is available in this document. To go back here again, and so whenever update or new record is created, that is what we do for every single record. Now, the next thing we do here is to see if it's an update, whether something has changed about this record, because it does not make sense to go and run the matching if nothing has changed, especially nothing has changed related to the match attributes. So if something has changed, only then we proceed. If nothing has changed, then we stop here. So this is what we have: rule configuration attribute value cleansed, whether the record is cleansed or not, whether it's an OV or not, and token phrases, right? And we'll talk about the token phrases in a bit. So let's say the record is changed. What happens then is that the record is then placed in the match queue. So this is basically the component that triggers the matching or the comparison part of it. Once the message is delivered here, the matching service is invoked and we trigger the matching or the comparison part. If the pair is found to be a potential match is created. If pair is found to be a match that has to be automatically merged, then the record is updated and put back in the CRUD queue and the cycle continues. Because remember, the moment you merge something, it's a change in the data. So now it is going back, and then it sees, after the merge, now do I have to recalculate and see, after I bring this new information from this other record, do I get more matches, or do I have to remove some of the existing matches on this? So that's what happens, and that's the cycle continues. So this is the tokenization process. So we are here now. When the match document is created, we create the token phrases. Now we'll take one example, Michael Branson here, and these are the tokenization rules. So basically, for simplicity, just think of this as every rule has its own tokenization rule, that gets constructed in the background. So let's assume that we have n rules here. So for every rule, we have tokenization rule. So by default, the rule is every attribute that has participated or that is configured as match attribute, they will basically be part of the token phrase. So this is how the token phrase looks like. So you'll have the first name, colon, last name, colon, address line 1, and so on. As you can see here, there are multiple rules or multiple tokens generating the same token. This can happen if these two rules are basically similar or are different, but when you tell system that, I do not want my last name in my token from the rule number 3, and after you calculate that token, basically the rule number 2 and rule number 3 is aligning on the same token. So that's how you could have multiple rules generating the same token, or same rule generating multiple tokens. This could happen if you are using some sort of fuzzy matching, right? So this is a good example again. Michael and Mike, two tokens to kind of facilitate that matching with Michael or with Mike. So you can have multiple tokens from same. There are certain conditions. If you have them in your match tool, then those attributes are automatically excluded from tokenization. That is exact or null, exact or all null, not equal and in. Okay, let's go look at the bigger picture here. So we have all these entities that are loaded in Reltio, right? So what happens is when the record is updated, let's say we have the first record E1 getting loaded here. So when E1 is loaded, it goes to the tokenization process that I talked about. And at the end of the process, it will generate these different token phrases. So this Smith colon Richmond is one of the tokens, or Michael Branson or whatever record we had there is one of the tokens. So what will happen is it will go and create all these buckets, but just the representation of that token phrase. Now the next record comes in and it basically generates the similar token. Let's say it generates E2 comes in and E2 also has the same token. So what it will do is it will simply associate that new record with the same token that already exists. Now the reason we do this, because if you did not have token, right, just imagine the only way you can match records is if you match every record in this data set with every other record. That's the only way you can match your entire data set. And that could take a lot of time. So that's why what we do is basically we create these smaller universes of data set, right? Anything that is part of this bucket, only those records are matched. So if you see something is not matching, then the first thing that you have to look for is whether they are in the same bucket, because for matching, this is the universe. And then it basically execute matching on this, goes to the next bucket, execute matching on that, and just goes through the entire list of buckets and does that. If two records are not part of the same bucket or same token phrases, they will never ever match. It's not possible. So this is just a way to kind of, create these smaller universes as I was talking about. So that's why this tokenization, like we keep talking about tokenization, is so important, because what you could do is you can say, I don't want to create tokens, so I'll just leave it like, no tokens, or I'll just leave the tokens blank. And if you put all of this, yes, it will basically go and match, but it will take forever, right? Now, if you say, I want to make sure I create a token such a way that, only 4 or 5 records, which is all I have, should match. If you do that too strict, then you might have under matches, because you want to basically keep them so that these are a possible candidate that you want to evaluate for matching. So that's why tokenization processes and tokenization configuration is super important, right? So let's see what happens once the tokens are created and how it is picked up for the match rule. And that basically will answer the question that Chris asked earlier. So I have 4 tokens for this entity E1. Once tokens are created and it is triggered for matching, Reltio platform will then pick up these 4 buckets because they all have this E1, and then construct this possible list of candidate across all these match candidate buckets. So you have E2, E3, E4, E7, E8, and E9. I got this list across of by scanning through all these buckets that it's part of. So if you have E1 and E8 as a pair in multiple buckets, that won't matter. It will be evaluated only once. So once this different candidate list is created, now these are the multiple match rules that we have. So there is no hierarchy in the match rules. All these match rules are triggered at once. Like so E1 and E2 will be picked first or in whatever order. And then we will execute the matching for all the rules at the same time, right? Now, for every rule, like I mentioned earlier, there's an action associated with it. If this rule evaluates this pair to be true, then whatever action we have configured for that rule 1 will be triggered. So let's say E1 and E3 is found to be a match, and this rule 1 is marked as automatic, then this pair will be automatically merged. And if rule N, for example, is a suspect, and again E1 and E2, this time different pair, is found to be true, then it will be submitted for data stewardship review. So this is how the overall matching works. So this is a end-to-end process. And one of the questions that was asked in the previous session was having multiple redundant match rules, does it hurt? The answer is, yeah, it does, right? Depends on whether you are having different tokenization scheme, because the more tokens you create, remember, it has to basically do those multiple evaluation, even if it is true or not. Let me give you an example here. So I have 6 records. As you can see, there are different versions of Michael Branson, 4 records, and the 5th record is Michael Branson, but he's from different states, could be different person. And then we have 6th record, Rachel Branson, which is a completely different person in the same state as the 1st record. So by default, what will happen is if you do not define any tokenization scheme, then this is what will happen. Every record will go in its own bracket or bucket, right? So you'll have Michael Branson, the 2nd record will get Michael spelled differently here. So they will never match with each other. So what do you do? The simple approach would be like, so say that just ignore the first name while creating the tokenization. So now you have Branson bucket with 145 Tommy. So now you manage to get these 2 records in the same bucket so that you can match them, right? But you still have the 3rd record, which is left out because the address line is slightly different. So what you can do is you can go again, or follow the same approach, leave the address line 1 out of the tokenization. So great, you have 3 records now. And you keep doing that until you get all the records, which is also the 4th record. So this time what you did is you took out the state as well, because it was spelled differently than this, just to get them 4 records. But this approach also took or basically brought other records in the same bucket. Rachel is also in the same bucket. Michael from different state is also in the same bucket. Now, this is what the problem is. You can still have them and write your comparison function in such a way that Rachel and Michael will never match, but you are still spending time in evaluating Michael and Rachel when you don't have to, right? So, okay, so this is basically the tokenization issues that we have. You have excessive number of tokens for an entity. So you have a lot of tokens. The time that we will have to spend in evaluating that record using this different token, which basically can cause performance issue. Some of the examples of this happening is you have fuzzy matching on more than one multi-value attribute. What that means is, like, if you have fuzzy on first name, fuzzy on last name, fuzzy on address, and these attributes are basically having multiple values. Remember, it has to create this token with different combination of all these different values. So the more values you have and the fuzziness to this, it will basically create a large number of tokens. We can obviously handle any number of tokens. It is just the time that it will be required to kind of process that, right? Let's look at the second issue, excessive number of entities sharing the same phrase. This is basically, it goes back to this scenario here. You have too many entities in the same bucket. So now it is evaluating every single record with every other record from that bucket. So you're spending a lot of time there. So those are the 2 main issues with the tokenization. How much time do I have? 5 minutes. So we'll answer questions probably on the community. Is that okay?
Do you have 10 minutes to go past, and I can just ask the questions here, we record them, and then we move on? Would that be okay, or do you have 10 minutes after this, or no? Okay, keep going, and I'll just ask them after this.
All right, so I'm going to go ahead and load all these records that I talked about, and I'm just going to okay. Okay, let's look at this. Okay, let me show you this Michael Branson, same address. Then I have this Michael or Michael spelled differently. Then I have this Michael, exactly same record. So it's basically the similar thing that we just saw with the Philip record, right? Let's refresh. And let's look at Michael Branson. Look at the potential match. And yeah, it worked, right? So you have Michael matched with Michael. We have Michael matched with Michael. Now, this worked because I do have those configuration in place correctly. So what I'm going to do now is I'm just going to go to rule number 2, rule number 3 here, and take out that configuration. I'm just going to take this out, and I'm going to say no tokenization. I'm just going to say fuzzy on the first name. The rule has not changed. I've just taken out the configuration, which tells you how the tokenization should be done and all. So if I go back. Okay, this is again triggering the rebuilding or rematching. So I'm going to post it again. Okay, there you go. So let's refresh. So as you can see, I lost that Michael one, or Michael spelled different, because now it is only matching the exact one. So if I open, it is still calling it fuzzy because Michael is also seen as fuzzy with fuzzy, but I lost that other record, right? So what I'm going to do is I'm going to put some of this back, and I'm going to say, okay, I want to do double metaphone so that Michael should match. And I'm going to do this. Okay, and the records again. Okay. Let's look at the file, whether it matched or not. Okay, this is the second record. Okay, you have to scroll down here. As you can see that yes, it matched. It says that it matched by document, but let's look at the UI. It's not there because you can see here it says the matched final outcome is false. What this tells you is that your tokenization is wrong or not sufficient for these two records to match at all. But if we were to match them without tokenization, they would match. That's what this means. So let's look at the tokenization here. So this first one is Michael. The other one is Michael here. But as you can see, there is no intersection, meaning there is no common token between this record. So that's what we have to do. So we have to go back here. And there are two ways. Like I said, you can ignore so that they basically belong to the same token. That's one approach. I'm going to put this back here and bring this records again. All right.
Suchin, I know it's top of the hour and most people are probably going to jump. I'm going to have Suchin still stay on for another 10 minutes to answer some of these questions. So if you want to stay on, that's great. If not, we certainly understand. And apologies about the audio stuff, but go ahead, Suchin.
Yeah. All right. So I changed that. And as you can see now, there is an intersection token here because I left the name out. And now I can see that it did match. And if I go to UI, then I will see that record coming back. So the tokenization is something that you have to carefully configure to make sure that you have the optimal performance and the desired output as far as the match pairs are concerned. Okay, so it's back here. That is all I wanted to cover in this session, Chris. So if we can go back to questions.
And if you want, you can stop sharing the screen if you like. So sure. Again, thanks so much for everyone for staying on. If you want to stay on, go ahead. I know Elaine had a question, but in the beginning you were showing your UI, and there was she wanted to know if there's a difference between lowercase fuzzy and uppercase fuzzy, because she saw that in the UI, or is it the same?
Yeah, the matching is case insensitive. So we just basically lowercase everything and then perform all this comparison. So you cannot match, or basically the matching of uppercase with the lowercase will still result in the match.
Okay. Any approaches to phase in match rules? So only triggering based on new or updated records and evaluate those to rest of corpus. So intent is to limit changes to downstream systems so that you'll have time to absorb. Does that make sense?
Yeah. So you still have to basically match the incoming. You're talking. Okay. Let me see if I get this question. A new match rule, right? So it works only on the new set of match new set of records, is it?
I could give some context on that if it'll help.
Yeah, please do.
Sure. So yeah, we're like going live. We're going to go live, and we have match rules that we want to have automated, but the disruption to all the downstream systems to get them all in at one time is going to be a problem. So ideally, what we like to do is have an automatic match rule only be driven by new content coming in, but as a new record comes in, match that to the entire corpus, but not bring the other guys together. So the driver is really a record coming in. So that way we can kind of reduce the traffic out. Does that make sense?
Yeah, sure. Yeah, it does. So by default, I want to share my screen again. I want to go to this record. So by default, you can change all these match rules here. And when and only when there is an update to the record which is changed is only goes to the matching. So for example, after you do the matching, let's say you change the rule and you added new rule, and only E1 is added or updated. Now, evaluation is done only for E1, not for all other entities. So you will see new sort of pairs for E1, and E9 might have new pairs, based on the new rule that you have put in, but that won't be executed until you go and trigger some sort of update to E9. So it works that way by default. But the moment you run the rebuild match table kind of job, it will trigger the matching and it will execute matching on the entire data set. But if you do not do that and just update the record, and you can put in new rules, so the new rules will be applied only to the updated records.
But when it does this, though, will it match, if the new record comes in, will it match that to earlier records that were there, or only to new rules that are coming in?
It will match to the earlier records using all set of match rules that you have in that configuration at that point of time.
And the changing from automatic to suggest, does that require rebuilding? We're literally
changing.
We're trying
changing from automatic. Sorry, go ahead.
Yeah, and maybe we could talk about it. I don't want to take too much time on this. If we could do some follow-up.
Sure.
Really helpful.
I can answer that question. If you go ahead and pose this question, I can answer with some examples on the community.
Sure.
Yeah, thanks, Mark, and we'll make sure to record that one too. So, and Sandro has a good question. He says, once a crosswalk is linked to a golden profile via match rules, I'm assuming change to the data in the crosswalk will not execute a new match. So like DOB has changed. So in other words, Reltio doesn't dynamically unmerge records as a result of a crosswalk data changes. Is that a valid assumption?
That is, yes, that is true. That is exactly right. So what happens is, like, when these records, let's say all these records merge into E1, and you change the match rule to say, I don't want to match on the last name anymore, but E4 was merged with E1 because they had the same last name. When you take out last name, this evaluation is not true anymore. So technically you should take them out, right? We don't do that automatically, but there are APIs available for you to kind of take that particular crosswalk out when there is a when there is basically a change in the underlying match rules. So there is no automatic unmerge that we support currently.
Okay. So is there anything they can do to configure changes to crosswalk that will trigger match rules?
The match rules are triggered, by the way. Question here is, once E1 is merged with all of these things, and let's say I change the match rule and E4 is no longer matched with E1, how do I take this crosswalk out? There is no automatic way of doing this. What you can do is you can basically write some sort of custom program to listen to that change, or whenever you change the match rule, you can evaluate this tree or this crosswalk tree, and you can say, is E1 and E2 still evaluates to be true? If not, then you can programmatically take the E2 out or E4 out. One other option is just to kind of break this group, but then you'll have to break every group that you have merged apart and then run the matching again with a new set of match rules. That is another option. That way you don't have to write that custom code, but you have to break all the groups and then let it kind of go through the matching again.
Okay, and there's so many more questions, so I'm just gonna ask one more, and then
Sure.
I'm gonna email most of these people that have the questions and ask them if I can post it as them, or you can go to community.reltio.com and post it yourself. And I'll make sure, Suchen, you will answer those, right? Just to make sure.
Sure. Yeah.
So one last question from Chetan, because I promised him I'd get this in. He said, he needed to know which is better comparator class. So cleanser for like country attribute, is match token necessary for country attribute?
Yeah, country attribute is one good candidate for match attribute, right? I mean, if your requirement says that I will never ever match my records from US with records from, say, France, right? Then country attribute is definitely a good match attribute, because what you're doing is you are making sure that the France record and the US record will never be in the same bucket. So that's why they will never be evaluated. So you're not wasting time in basically even considering them. So yeah.
Great.
Sorry, a small question on top of this, Chetan. So what will be the best practice for the comparator class? Say, for example, for address, we have address comparator. So for country, basic comparator is okay, or we need to specify something else?
Yeah, basic comparator is fine, provided you have standardized that, right? If you have standardized all the country code, then basic comparator is fine.
Okay, sure. Thank you.
Great. Actually, there's not a ton more questions, so
Sure.
there's a few, but that was good. So what I'll do is, I know there's only 25 more people on here, but I'm going to share this out to the community. Hopefully this was helpful. I know somebody said this is one of the best sessions so far. So when I do share this out, I'm going to cut kind of the blank out. So, but yeah, so thank you everyone. This was really a good session. I think, folks are really wanting this. But stay tuned. We'll have another session in the next couple of weeks. My hope is to continue these on, and I'd like to try to, starting September, to have one a week if possible. Thank you everyone for staying on late. That stayed on late. This will be shared out probably next week on the community. So thank you everyone. Take care, and Suchen, nice work.
Sure. Thanks.